Now that you have an understanding of earthworms and what segmentation means, I want to talk about a sister group to them and look at the mollusks. So when we look at mollusks, you may know many of these as squid and snails and oysters and so on, but there are actually 8 totally different classes of mollusks. So remember, phylum, mollusk, and then class would come right under phylum, right? So it's kingdom, phylum, class. So of these, we see huge differences in body structure and design. We see differences in habitat, eating, reproduction, all of those major things. I want to focus with you on 3 important classes of mollusks, and I think these will be the ones that you're most familiar with. The gastropods, or the snails, the bivalves, and the cephalopods. So when we look at these different organisms, they really are completely bizarre in their structures, right? So clam, you're probably familiar with, squid, and so on. But when we look at things like chitin, this is what we think is actually the ancestral mollusk, so it's very interesting from an evolutionary perspective. But if I gave you the 6 organisms that are on this slide, would you actually put them into the same group? Well, they're all in the same phyla, right? So they're all in Phylum Mollusca. But they're all different classes. So when we look at their structures, we're going to look at, in particular, their heads and their feet. And I'll show you why. Our hypothetical ancestor for all of our mollusks, as I mentioned to you, is the chitin, C-H-I-T-O-N. Please be careful with this. We'll see chitin, C-H-I-T-N, later on when we talk arthropods. So you have to be careful with that word. But this idea of this hypothetical ancestor gives us basic structures. In particular, it gives us a basic body plan. It's going to give us the necessary components to build a more complex animal. So the gastropods are what we refer to as stomach-footed. So gastro is stomach, pod is foot. So then with our cephalopods, head-footed, and then bivalves, meaning 2 shells. So these will be your clams, oysters, scallops, things like that. But again, even if I give you these 3 things, you might be hard-pressed to put them into the same class and categories. Now, they're in different classes, so that's what we're going to focus on. The basic body plan of a mollusk, as I mentioned, is essentially foot and head. Foot and head. Okay? So when we look at these structures, what we want to look at is, why are they so different? Why have they diversified so much from that original chitin that actually kind of looked more like a snail, right? So the foot is always very muscular. So whether you're a snail crawling around on your foot like this, whether or not you have tentacles for feet, they're still very, very muscular. The other thing we look at is something known as a radula. This is probably a new term for you. It is associated with the mouth and the ability for the organism to literally scrape surfaces to get food. When we look at our clam here, he doesn't have a radula, but he does have siphons, so he's constantly bringing in food that is getting absorbed and processed. Now, there are a whole lot of organs going on here. For any of you who have ever eaten a clam, you may never eat one again after seeing this, and I'm sorry about that. They are quite tasty. But when you look at these organ structures, we see these big muscles. And for those of you that have eaten a clam, you know these muscles sit on the sides. It's actually what holds the shell shut. We also look at the development of a heart and a kidney, digestive glands, all kinds of things going on here. And that thing that sticks out that everybody refers to as a tongue is actually the muscular foot of our mollusk. So it will allow that clam to bury down in and protect itself. Now, when we look at mollusks, we start to see more of this metamorphosis, or the change that occurs during development. So this is actually a larval stage of our mollusk. It doesn't look anything like the mollusks I've just showed you. I understand that. So it's something known as a trochophore. And when we look at these intermediate larval stages, I just want you to be aware that many of these organisms are going to release eggs and sperm often into the water. They're going to join and form these free-swimming larvae. And then those larvae will develop into the direction of the class of mollusk we've looked at. So like we said, this muscular foot. Now, oysters actually have lost that muscular foot, so this is something we call a reversal in evolution. So their class had that foot and then have lost it. Or like we saw with the tentacles on the squid, we can see a lot of different structures and variations on this muscular foot. So here's our clam bearing down into the sand. The muscular foot on the snail is much more obvious for us. That radula we talked about, used to scrape surfaces for food. I'm going to show you a picture here. You see it has these hard plaque-like structures on it. Some folks refer to them as teeth. So they literally are going to push this out. So this is their big tongue. They're going to push this out and literally with a licking motion, they're going to lick the surface and scrape off things like algae and mosses and lichen and other things that would be food particles for them. So this is a basic kind of structure. This actually is most like our chitin, or our ancestral organism we were looking at. So here's an SEM, the surface structures of our radula, so you can see it. And you see the snails crawling along. Unfortunately, we can't get close-up video of our snail radula scraping along the moss, but you get the idea that they're working very hard, licking these surfaces and getting food particles to move up into their mouth so that they can get the nutrients that they need. Other things we mentioned, heart and kidney and stomach. We do see that most mollusks are going to have an open circulatory system, meaning that they don't have an extensive amount of blood vessels. The cephalopods, though, do. They've got a closed circulatory system, but if you think about the shape of our squid that we saw earlier, if he had an open circulatory system, all of his blood would just drain out of his head, right? That's not going to be effective at all. So we do see clams and such that have this open circulatory system. It essentially means that the blood is drained into something known as sinuses. So these are kind of like the sinuses in your head, in that they're just open spaces. And when the blood is in these spaces, it essentially just surrounds the organs and they pick up the oxygen and nutrients that they need simply by diffusion. Reproduction in our mollusks is almost always sexual. And when we look at this reproduction, it can either be in separate sexes or we can have hermaphrodites again. So gastropods and bivalves can be either. Cephalopods are actually all hermaphroditic, so they're all female and male and carry those components together. They actually decide when they join together in squid love, they'll actually decide at that point who's going to be male and who's going to be female for the day.